Hello guys, so let's learn about prefix sum. So here is this question. Given an array A with n integers and an array Q with m queries, we need to find the range sum for each query. So let's understand with an example here. Suppose you have an array A. It has 1, 2, 3, 4, 5 inside of it. And you also have an array Q. It has queries inside of it. Okay, so how a query looks is like this. 0, 3, 1, 3, and 2, 4. So these are 3 queries in total. So what we need to do is, for each query, you see each query has 2 numbers. First one is L, second one is R. So left to right. For each query, in this range L to R, we need to find the sum of elements of A. Okay. So for query 1, 0, 3. So from 0 to 3, we need to find what is the sum. So this turns out to be 10, 1 plus 2 plus 3 plus 4. Hence answer for query 1 is just 10. Similarly, for query 2, we need to go from 1 to 3. 2 plus 3 plus 4. This comes out to be 9. For query 3, just like this, we need to go from 2 to 4. So 3 plus 4 plus 5, this comes out to be 12. And this is our answer. I hope you understood the question. Okay, so now let's try to solve it. So the first approach is the brute force approach. So this is the first thing that comes into our mind. So what is it? Basically, if I have A, whatever it has, let's say 1, 2, 3, 4, 5, and then I have Q with, let's say 3 queries, again I'll take the same ones, 0, 3, 1, 3 and 2, 4. If this is the case, then what we can do is, we go over each query. So basically we iterate over the Q array. So first we go to 0, 3 here. Okay. And then we go and find the sum of 0 to 3. And whatever is the sum, let's say sum came out to be S1. We put that S1 in answer. Then we go to query 2. Do the same for 1, 3. So from I is equal to 1 to I is equal to 3, we iterate over A, get the sum. Let's say this is S2. And we put that S2 in our answer. Then we go to query 3. Similarly, from 2 to 4. So from 2 to 4, index 2 to index 4, we get the sum, which is S3. And we put it in the answer. So this is basically a simulation of the most basic thing that we do. Okay. We put this inside an answer, we return the answer. So now let's see how to do it. Like, what is the pseudocode for this? Okay, now let's take a look at this pseudocode. This is not code in any particular language. It is just a pseudocode, a kind of a blueprint of the code. What you can do, you can translate this into any programming language that you wish. Although in the description, you will find code for C++ and JavaScript. Okay, so first we get an array, answer. It is empty initially. Then we iterate from 0 to m minus 1. M is the size of Q. Okay. So we are basically iterating over the Q array. For each query inside the Q array, we extract L and R. So let's say this is the Q array. First query is 0, 3. So for I is equal to 0, I am here. Now when I'm here, then Q of I, which is basically this thing, and Q of I of 0 will be this. So L will have 0 inside of it because Q of I of 0 is 0. Then Q of I is again this, and Q of I of 1 will be this 3. So R will have 3. And then we initialize S is equal to 0. And then what we do is we iterate over A. So A was, let's say 1, 2, 3, 4, 5. So from L to R, so from 0 to 3, we are going to iterate over A and get the sum. And the sum, whatever it is, in this case it will come out to be 10. We push inside the answer 10. We do this for every query inside the array Q. And that's how we'll get the complete answer. Now let's talk about the time complexity for this. So if I take a look at this, then clearly I can see that the outer loop is running m times. Nice, but how many times is the inner loop running? Now this is the problem. We cannot figure out how many times the inner loop is running without knowing the array cube beforehand. And that is not possible to know beforehand. So what you do in such cases is you guess the worst case. So guess the worst case scenario, and whatever number of times the loop is running in that case, use that here. Okay, so what will be the worst case? In this array, we are iterating over A. The worst case would be when I have to iterate over all the elements of A. So basically, worst case is when L is equal to 0 and R is equal to N minus 1. N is size of A. So in that case, in this worst case, how many times will A run? Will the J loop run? N times. We are iterating over each element of A. N times. So M into N. Time complexity is M into N. Is this good? Actually, no. We can optimize this using prefix sum. So now let's see that approach. Okay, so what is prefix sum? So it is just a technique, a very common technique. What you do is, if you have any array A, okay, let's say it has simple 1, 2, 3, 4, 5 inside of it, then the prefix sum array of A will be 1, 3, 6, 10, 15. So what I'm doing is basically, at any particular I, it holds the sum from 0 to I. So here it is 6. So in A, from index 0 to this particular I, what is the sum? 1 plus 2 plus 3, 6. Hence 6 is here. Okay. So if I have to make it from scratch, what I'll do is, first one will be simply 1. Then for second, after this, second one, 1 plus 2, 3. Then 3 plus 3, 6. Then 6 plus 4, 10. Then 10 plus 5, 15. This is how you make it. Okay? But essentially, what is it? Basically, what it is telling is, pre of I is equal to sum of all A of I from I is equal to 0 to I. Basically from 0 to I. Okay, it is not mathematically right. I have to write 0 to I. So pre of I is summation of all elements of A from index 0 to index I. That's it. This is how you make it. But what is the use? Let's see that. The use is actually very simple. If I have the prefix sum, let's say A is, let's take a better one this time. Minus numbers are also there. Negative numbers are also there. This is the case, let's say. What will be the indices? 0, 1, 2, 3, 4, 5, 6. If this is A, then let's first write the prefix sum array of A. It will be minus 1. Minus 1 plus 0 will be minus 1. Minus 1 plus 1 will be 0. Then 0 plus 2 is 2. 2 plus 3, 5. 5 plus 4, 9. Then this will be 14. 9 plus 5, 14. This is the prefix sum array. Why is this useful to us? Is this. Let's say my query is 0, 2. What does this mean? I want sum of all A of I from index 0 to 2. That's it, right? Which is nothing but pre of 2. Okay? It will be 0. We can cross check. 0 to 2, basically this range. Minus 1 plus 0 plus 1, this will be 0. Hence, answer is 0. And it is kept here. Easy. Similarly, you can go from 0 to 6. This will be simply 14 because it is here. Okay, and 0 to 3. 0 to 3 is this window. It will be 2 because pre of 3 is 2. That's it. But I think now you know the problem. Okay. The problem is, what if my range is something like 3, 6? This is my range. Now, what to do in this case? Because the prefix sum only contains the sum of elements starting from index 0. I want from 3. So what to do in this case? So here what you do is you just use a little bit of head here. You see, I want from index 3 to 6. I have already, if I just draw a small number line here. So 1, 2, 3, 4, 5, 6. These are the indices, okay? The indices. I already have from this, that will be 0 also, 0 to 6, okay? Let's call this S1. I already have 0 to 2. Let's call this S2. I want 3 to 6. 3 to 6 is this part. Don't you think if I do S1 minus S2, then I will get this range 3 to 6? Correct? So what I'm trying to say is, if I want in this particular array, if I want the range 3 to 6, answer for this query 3 to 6, what I need to do is, I just check pre of 6 first. Pre of 6 is 14, okay, 14 minus pre of 2. Pre of 2 is 0. So 14 minus 0, whatever it is, that will be the answer for this query. Let's count it. Let's count it quickly. 2 plus 3 plus 4 plus 5. This is the range that I wanted, 3 to 6. 2 plus 3 plus 4 plus 5. So 2 plus 3, 5. 5 plus 5, 10 plus 4, 14. This is correct. Okay, absolutely right. A very simple logic. But can you guess what? Okay, I'll just write a general equation for this. So in general, we can say pre of I is equal to sum A of I goes from 0, okay, 0 to I, whatever it is. Good. Okay, I can write x here. X is equal to 0 to x is equal to y, which is basically just this. A of 0 plus A of 1 plus A of 2 up to dot 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 A of I. Okay, this is the most accurate mathematical thing. I can also say that if I have a range for, let's say x comma y, the sum for this range will be pre of y minus pre of x minus 1. I can say this as well. This is what we did exactly here. Okay. So 3 comma 6 was pre of 6 minus pre of 3 minus 1, 2. So if I write this, these are the two important results. Based on this, I'll be able to solve this question. But there is a flaw in this, a very small one. The problem is, what if x is equal to 0? If x is equal to 0, then 0 minus 1 will be minus 1. And pre of minus 1 does not exist. And in fact, in most programming languages, if you try to access an index which is not from 0 to n minus 1, then you'll get an error. It will basically crash your program and it will throw an error. So what to do in this case? Because there can be a range 0, 7. What you do in that case is you just return pre of 7 because that is the answer. And ignore this part. So what we need to do is we need to check if x is 0, then just return pre of y. If not, then return pre of y minus pre of x minus 1, because if x is not 0, then this value will not be negative, because we are talking about indices here. X is an index basically. Okay. So based on this, now let's write the pseudocode for this one. Okay, so here is the pseudocode for this particular program, the prefix sum method. So there are two parts. This is part 1. This is where we create the prefix sum array, and this is where we use it to get our answer. Okay, so let's take a look one by one. So what is happening in this? We have initialized a pre-array, empty array, and we also have basically a variable s initialized with 0. Now, we iterate over a going from I is equal to 0 to n minus 1, and we calculate the sum for each element. Okay, so basically if A is 1, 2, 3, 4, 5, we basically just calculate the simple sum of an array. Okay, so when I is here, sum will become 1, then I plus plus, sum will become 3, then I plus plus, 3 plus 3, 6, then I plus plus, 6 plus 4, sum becomes 10, then it becomes 15. Only thing different is, in each step, we are also pushing the current sum inside pre. So, when sum became 1, we pushed that 1. When sum became 3, we pushed that 3. When sum became 6, we pushed that 6. When sum became 10, we pushed that 10. When sum became 15, we pushed that 15. And then that was it. And we get our prefix sum array this way. Okay, simple, very simple. What is the complexity for this part? Simple, we are going from I is equal to 0 to n minus 1, n iterations. So this is big O of n. Okay, nice. Let's move on to this part. I'm going to erase this. Okay, now I have A is equal to 1, 2, 3, 4, 5. I have pre is equal to 1, 3, 6, 10, 15. My query array Q has queries 0, 3, 1, 3, and 2, 4. Now, coming to this part. First, we have an empty array answer. It is an empty array. We'll push one by one, whatever is the answer for each query, we'll push into this. Now, we iterate over the Q array, this array, 0 to m minus 1. M is the size of this array. So, in this case, m will be 3 because there are 3 queries. Okay. So, initially, I will be 0. So, I is here. Okay. I is equal to 0. Now, what is the value of L? What is the value of R? So, Q of 0 of 0. I is 0. So, Q of 0 of 0, answer is 0. So, L is 0. Then, R will be 3. From 0 to 3, we need to find the sum of all elements in A. Range is 0 to 3. So, how to do that? This is where this if else will come into place. If L is equal to 0, yes, it is. So, sum is equal to simply pre of R. So, pre of R is 3. So, pre of R is 0, 1, 2, 3, 10. Sum is 10. So, push this 10 inside answer. Okay. Now, I plus plus happens. I is here. Now, this is the second query. So, I is 1 now. What is L? L is 1. What is R? R is 3. Is L is equal to 0? No, it isn't. L is not 0. L is 1 actually. So, sum is equal to, we'll go into else part, and sum will be equal to pre of 3, which is R, pre of 3 minus pre of 1 minus 1. So, basically pre of 3 minus pre of 0. Pre of 3 is 10. Pre of 0 is 1. So, this comes out to be 9. So, sum is 9. Push this inside the answer. Now, again, I plus plus happens. I is here, 2, 4. So, L is 2, R is 4. Again, L is not is equal to 0. So, go to your else part. Sum will be pre of R. R is 4. So, pre of 4 minus pre of L minus 1. L is 2. So, 2 minus 1, 1. Okay. So, now just get this value. Pre of 4 is 15 minus pre of 1 is 3. 15 minus 3, 12. So, sum is equal to 12. Push this 12 inside your answer. And hence, you get your answer. This is right. 10, 9, 12. We've already seen this. Good. So, this works. What is the complexity? So, I'll just erase all this working now. So, if I see this second part, it only has simply one loop. Inside everything is constant. There are no loops inside it. So, this loop, how many times is this going to run? It is going from 0 to m minus 1. So, clearly this runs only m times. So, total complexity is just big O of n plus m. Okay, so we came down from n into m to n plus m. This is a huge difference. This is good. But what about space complexity? Earlier, space complexity was constant, big O of 1. Okay, so where was it? In this example, time complexity is m into n. but space complexity is constant, big of 1. We are not declaring any array or anything. This answer is part of our output. Input and output is never considered inside space complexity. So we will not consider array A, will not consider array Q, will not consider array answer. Okay, without all these, we have not created anything like apart from these. So space complexity is big of 1. But in this case, space complexity will be big O of n. Why? Because answer is here, A and Q are provided as input, but we have also created this pre-array, which is size is same as array A, which is n. So space complexity this and time complexity this. Is there a way to reduce the space complexity from big of n to big of 1? Basically what I want to achieve is time complexity should be this only, n plus m, but space complexity should be big of 1, not big of n. So you can actually do that, but there is a sacrifice that you need to make. So remember, you have A. Instead of making another array pre and putting S inside it, 1, 3, 6, 10, 15, what you do is don't make this. What you do, just update, overwrite the values in A itself. So 1 is overwritten by 1. Then 1 plus 2 is 3, so put 3 here. Then 3 plus 3 is 6, put 6. 6 plus 4 is 10, put 10. 10 plus 5 is 15, put 15. So this A will act as your prefix sum array itself, okay? But the sacrifice is that now you don't have the original A. The original A array is gone, it is lost, okay? So you can do this only when in your problem you need prefix sum and you don't need the original array after you have the prefix sum. And that was, this is what was happening in our case. See in the program, once we have the prefix sum, we don't need the original array. See, in this part, original array is not needed at all. So we can reduce from O(n) to O1, okay? But if there is a problem which is using the original array again, then you cannot do this, okay? So that was it. A very important problem on prefix sum. It explains everything related to prefix sum. In the next few videos, we'll cover few very important problems where prefix sum is used not as the primary thing, it is a secondary thing, basically applications of prefix sum. You'll love it. I hope you understood everything. Thank you.